So right, what is given? Sum of the squares. So it is a total of some square value. We are identifying is the square of which value. What is the next line given? Sum of the squares of the deviations. Deviation is what is the meaning of? Deviation is say mathematically. In a deviation is difference. It's a deviation is also meaning difference. For difference, what is the mathematical notation? Minus. So it is some subtraction of two terms. Okay. So it is the sum of the squares of difference. What happens again? So now we have to identify the difference of which two values. So what is given? Deviation of the sample values from the sample mean. Okay. Not the how we denote the values is sample values. So it is the difference between the sample value is and sample mean. What is the notation for sample mean? X bar. So this is the value which is given for. Okay. Sum of the squares of the deviation of the sample value from the sample mean. So you are given that this total value is for what is the first value of 120. For first sample, this is the given information. Can you understand? So you are not given the average or you are not given variance or standard deviation. You are given only this two. Okay. Similarly, the same information is given for the second sample. For the second sample, it was given to be 314. So we will assume the second sample to be 1. So what is the other information given is? Summation of y minus y bar the whole square equal to 314. Now this is the information input. Which formula will apply? Can you go for mean formula now? No, because to apply mean formula means we should know x1 bar and x2 bar. Whether that is given here? No, so we can't go for mean formula. So what is the only possibility? Variance. Because based on variance, we have a formula based on this one to calculate x1 and x2. Okay, can you understand how to identify? This is another way of asking the problem to make you think instead of very direct information. Okay, understood this one? So what is the meaning of sum of the squares of the deviation from the mean value? Summation of x minus x bar the whole square. Okay, well, understood? Don't forget this one. So start the solution. Given n1 equal to 10, n2 equal to 12. Summation of x minus x bar the whole square equal to 120. Summation of y minus y bar the whole square equal to 312. What is h naught now? What is supposed to check? What is supposed to check? Test whether the difference is significant. Okay, so what we have h naught? Sigma 1 square is equal to sigma 2 square. So right, h naught sigma 1 square is equal to sigma 2 square. What will be h1? Not equal. So sigma 1 square not equal to sigma 2 square. Okay. Now what is the next step now? We have to write a statistic. But to write a statistic, we should know what is x1 square and x2 square. So start calculating that one. Right. Capital x1 square is equal to summation of x minus x bar the whole square by n1 minus 1. That is a formula in terms of this table. So it is 120 divided by 9. What is now? 3.14 table value. F alpha 3.14. Now conclusion, accept or reject? Accept or reject? Accept, because the calculated value is less than the table values, we are going to accept H naught. So right, since modulus of calculated value is less than modulus of table value, modulus of calculated value is less than modulus of table value, accept H naught. Accept H naught. Accept H naught means what is the conclusion? Giving a statement. Difference is there or not? There is a difference. We are accepting H naught or rejecting H naught? Accepting. So you are saying that sigma 1 square equal to sigma 2 square. Where there is a difference? No difference. Right. Hence, there is no significant difference. Hence, there is no significant difference between the given data. There is no significant difference between the given data. Any doubts, ma'am? Clear? Yes? So we are going for the next topic, ma'am. Here we are going to discuss for the single variance or standard deviation. Okay, so take our next topic. Test for single variance. Test for single variance. Single variance. So right, the test statistic is chi-square is equal to n minus 1 s square by sigma square. N minus 1 into s square both divided by sigma square. Next line. This statistic follows chi-square distribution with mu equal to n minus 1 degrees of freedom. With the mu equal to n minus 1 degrees of freedom. So for single variance, what distribution we will make use of? Chi-square. Okay, some questions can be asked. What are the applications of chi-square, or what is the use of chi-square? What you can write? It can be used for testing for significance of single variance, then results of it and independence of attributes. All these three are applications or uses of our chi-square. Okay, so all the other procedures are same. Okay, so take a problem with individual lines at its various windows, comma, a post office finds that the standard deviation for normally distributed waiting time for customer on Friday afternoon is 7.2 minutes. 7.2 minutes. Full stop. Friday afternoon is 7.2 minutes. Full stop. The post office for customers have a standard deviation of 3.5 minutes. 3.5 minutes. Full stop. With a significance, continue. With a significance of 5%. With a significance of 5%, comma. Test the claim that C-L-A-I-M, claim that a single line causes 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 lower variation among waiting times, open a bracket, right? Shorter waiting time, close the bracket. For customers, okay. Now question is over. Read the statement and identify what is given. Read it. What is happening? You are discussing about which place, ma? Post office. You are giving the information based on what happens in a post office. Okay, wow. So what is the waiting time given for that one? 7.2. That waiting time is based on mean or what are the value? What value is given? We are given 7.2, no ma. It indicates which value? Standard deviation. A post office finds that the standard deviation for normally distributed waiting time is to be 7.2. This is a general information or a sample information, ma? Sample. Give it clearly. Sample or general? General, because they have not mentioned that they have taken this from a sample. Overall, they are saying that the standard deviation of the waiting time will be 7.2. So this is the population standard deviation. What is the notation? Expert. Population standard deviation. Sigma. Still you are not following the notations. So right, given sigma equal to 7.2. That is the first information we can identify. Sigma equal to 7.2. Now read the remaining statements. What they are doing? Random sample of 25 customers. So how many samples you are taking? 25. What is this 25? N, small n. N equal to 25. Large sample or small sample? Small sample. Small sample. Greater than 30 means it will be large sample. Less than 30 means it will be small sample. Now you have identified it is to be a small sample. Okay. What is the next information given? This 25 customers have a standard deviation of waiting time to be 3.5. What is this 3.5? Standard deviation of sample. Okay. What is the notation for that one? Small yes. Sample standard deviation is small yes. So right. Small s is given to be 3.5. Now this is the information given, right? You have decided that it is small sample. Single data, double data. Single data, double data. Same that we are discussing about only one sample. This is only one set of information, so single data. Single data means you can solve it by either mean or variance. This one you can solve by mean or variance. Variance. Why not mean? Because no mean values are given. Mean values are not at all given, so we can solve it by mean. We know only the standard deviation, so we can solve it only by Okay, என்ன வேல்யூ கொடுத்துருக்காங்க get one rotation மாத்திக்கோ. If you feel confused means have it as a standard assumption with variance itself. H naught sigma square is equal to sigma naught square. Okay, so right? H naught sigma square is equal to sigma naught square. That is a standard assumption. So now you write for this problem. For this problem, what will happen? H naught sigma square is equal to what is given? We have written the given data now. We are given sigma as 7.2. So what means sigma square? 7.2 square. Because we are given sigma. Okay. Listen. Which one? No need to calculate that one, ma. We are just making an assumption. No need to convert it as a value. Listen 1 minute. In the statement, instead of standard deviation, you are given that variance is 7.2. How do you write this one? Variance is given as 7.2. So how do you write this assumption? For each text you may use of different tables. Don't make mistake here. Now conclusion, accept or reject? Reject or accept? Why reject, ma? Calculated values greater than table value. Is it so? What is the calculated value? 5 points. What is the table value? 36 points. Accept or reject? Accept. So right. Since modulus of calculated value is less than modulus of table value is less than modulus of table value, accept H naught. Accept H naught. So accept H naught means what is the conclusion, ma? Sigma square
Equal to
whether the claim is right or wrong, ma? Whether you can accept the claim or not? Accept that. Not accept. Give me one conclusion. Whether you can accept the claim or not. You are accepting H naught, ma. Accepting H naught means you are saying that sigma square will be only 7.2 square. Okay, the meaning claim is accepted or not accepted? Not accepted. Only in H1 you have said that sigma square will be less than 7.2 square. Andala compare to the statement is only thing. We have rejected that one. So whether the claim can be accepted? No, the claim cannot be accepted. So right. Hence, the claim cannot be accepted. Hence, the claim cannot be accepted. Now start thinking, ma. If you are not able to understand the statements and if you are not able to think means, you can't solve the problems. Claim cannot be accepted. Okay, ma. Any doubt? Any doubt in your first problem? Okay. Take down next one. Second problem. Second one. As of a survey, comma, as of a survey, comma, the standard deviation as of a survey, comma, the standard deviation of internet speed across ISP, capital I, capital S, capital P. What is ISP, ma? Internet Service Provider. ISP was 12.2%. Was 1% level. Promise not literally drawing but give you a conclusion. Okay, draw a conclusion at 1% level. Now read the statement and identify what is given. What is the first line given? The standard deviation of internet speed across IPS was 12.2. Okay, this is a general information or sample information. General. So you are given general standard deviation. So what is the notation? Sigma. Okay, you are given the information for populations. You are given sigma equal to 12.2. Right. Given sigma equal to 12.2. They have found out the speed is 12.2%. So next what they are doing? Sample of 15 is taken. What is this 15? Yeah. Right. Small n is equal to 15. For this, the standard deviation is 13.2. What is that one? Small s. Small s is equal to 13.2. Now we stop after this one. See the statement and tell me large sample or small sample? Small sample. Single data, double data? Single data. So you can solve by mean or standard deviation. This you can solve by standard deviation because no mean values are given, so we can solve it only by standard deviation. Now we have to decide your H naught. What is H naught? Sigma square is equal to sigma naught square. Here sigma is given. What is sigma? 12.2. So write H naught. Sigma square is equal to 12.2 square. Sigma square equal to 12.2 square. What will be H1? Greater. How do you decide that one? The analyst has said that the internet speed will be O. You are supposed to check this statement. So you have to assume sigma square greater than 12.2 square. What type of test? 1 failure. Greater than means 1 failure. Now calculate chi-square. Right? The test statistic is chi-square equal to n minus 1 into s square divided by sigma square. N minus 1 into s square divided by sigma square. Find what is chi-square. What is chi-square? Calculate now. 16.38. 16.38. Everybody getting same answer? Next to decide alpha and degrees of freedom. What is alpha given? 0.01. 1%. Alpha equal to 0.01. Then table value, degrees of freedom. Degrees of freedom is n minus 1. 15 minus 1 will be 14. Find chi-square alpha table value. 29.141. Right. 0.01 and degrees of freedom is 14. Chi-square table. Girls, what is the answer now? 29.14. Table value 29.14. 29.14. So accept or reject? Accept. Again here also the calculated value is less than the table value. Right. Since modulus of calculated value is less than modulus of table value, accept H naught. Accept H naught means what is the conclusion? Simple come. Reject H1. So what is the conclusion? Claim cannot be accepted because this claim is not true. So right, hence the claim cannot be accepted. If you want to give an elaborate answer means hence the claim of the analyst that the speed is more than what is given is not acceptable. You can write like that. Anyway, it is short form of conclusion or longer form. Your choice. Any doubts, ma'am? What are the tests we have discussed for small sample? Single mean, difference of mean, single variance, difference of variance. Apart from that one, generally we discussed what is goodness of it and independence of attributes. That is a general topic that does not come under small sample or large sample. That is a general way of discussing one concept there. Okay, small sample only 4 formulas. Okay, in difference of mean there will be 2 formulas, independent data and paired data. So totally 5 formulas here for small sample. For mean, single mean and difference of mean, you will be using T distribution. Single variance, chi-square distribution. Difference of variance, F distribution. Okay, for each one the degrees of freedom will also vary. All these things should be first studied thoroughly. This should be written by you. Okay, I always ask you to make ready with the formula list. Have you done that? Day 1 when we started this unit, I told you. Completed? What are the things you should note down, ma? Your title should be small sample. First test, single mean. What is the test statistic formula? What is the degrees of freedom? Difference of mean, 2 categories. Independent data, paired data. Their corresponding formulas and their corresponding degrees of freedom. Okay, similarly for single variance and difference of variance. Formula, degrees of freedom. Like this you should have written that one and you should have with you and you should be studying that formulas frequently. Then only it will get memorized. Okay, because so far we have discussed only the small sample. Now we are going to discuss with the large sample. For that also you will get another set of formulas. Okay, well, no confusion should be there. Is that clear? Listen, now we are going to start with the large sample concept. So here also we are going to discuss 6 different tests. Okay, wow. Here are the like similar to the small sample, the same will be 4. Single mean, difference of mean, single variance, difference of variance. Apart from that, we will be discussing for single proportion and difference of proportion. That is based on probability values. So totally 6 tests we are going to discuss in large sample. So all the other hypothesis procedure is the same thing. Okay, there will be a difference in the formula. What is the advantage here is that for all the 6 tests we are going to make use of only the normal distribution. Okay, in small sample for each one we use different one. But here for all the 6 we are going to make use of only the normal distribution assumption. Okay, but directly we are not going to make use of normal distribution. So everything is converted to a standard values. Here we discuss the table value. For each distribution we decided alpha and we decided what is the degrees of freedom and then we have written the table value. But here there is a set of standard table